Hi again. In this video, we're going to keep talking about slope, but in a slightly different way. Instead of just looking at an algebraic equation and seeing what its graph looks like and all that, we're going to look at it in more of a context. And so the way that we can interpret slope in a context, and actually we're going to be talking about slope for the whole semester pretty much. We're going to expand our idea of slope into really a much more general sense than just equations of lines. It's super cool. I know that you'll love it. But in this context for now, one way to interpret slope, no matter what kind of thing that you're looking at, is by thinking of it in a rate of change context. Okay, so it's how much does the output value change? We usually call that y. It's the rate of change of y, or the output, for a unit increase in x, or the input. Okay, now unit increase, that just means up by 1. Okay, so that's just the standard like run unit. So the slope tells you the rate of change of y, how much does y change, the output, if you increase x by, or the input, by 1 unit, no matter what it is. So for example, in example 1, if we have a town's population, and we'll call it P, so that's our output, capital P for population, is initially 30,000, and the town grows by 2,000 people per year, we find a formula for the population as a function of the time t, little t, in years. Okay, so this notion of rate of change for unit increase in x, well, that's present in this example by this 2,000 people per year. Right, our input variable here, our input variable is t, little t. Okay, so and our output now is capital P. So little t is time is playing the role of x, and capital P is playing the role of y. So this tells us that this 2,000 people per year, unit increase in time, this is the change in population. So this is actually the slope. And the 30,000 initial population, this is the intercept. Okay, so if we were going to write a formula for P, capital P, then this would be 2,000 people per year, so 2,000 times t, and then plus 30,000. And this would be our equation. Okay, you start here. Every year you increase this by 1, you're just going to add on another 2,000 people. Does not sound sustainable for a town, but you know, this is a simple example. Okay, so in the second example, we have a car's value depreciating over time. So when you buy a new car, the second you take it off the lot, it starts to lose value right away. So in this example, we have a new car that costs $23,500. And in 3 years, the value has depreciated linearly to $18,823. I want to find a formula for the car's value V in terms of its age t in years. Okay, so just like before, how we had that initial population, that was our intercept, we can think of this initial value, or the value at the beginning, as the intercept. So this 23,500 is the intercept. Now the depreciating linearly, this tells us that the way that the value equation can be written is in mx plus b form. But here our input variable isn't x, it's t, so it'll be mt plus b. Okay, so we already have b, that's this, and we have to find m. Okay, so here we have basically 2 points on the equation, or on the graph of the equation, right? So we have 0, 23,500, and we also have that 3 years later, the value is 18,823. And so we can use these to find the slope. Okay, now normally m, the slope, is change in y over change in x, but here it'll be change in v over change in t. Okay, so let's see, you can do it in either order when you subtract. I'm gonna take this point and then I'm gonna subtract this point. So for the change in v, I'm gonna say 18,823, so the value at 3 years. And then I'm gonna subtract the value at the beginning at 0 years. And then underneath, they just have to kind of match. So at 3 years, we had the 18,000, and at 0 years, we had 23,500. All right, so what this comes out to be, if you subtract the numerators, the numbers in the numerator, let's see, you get negative 4,677, and then that's over 3. So this represents that in 3 years, the car will lose $4,677. Okay, so this is like dollars up top, are the units, and then years in the bottom. But again, with slope, we want it to have a unit change. So we want to know, it makes more sense to us if we could say in 1 year, how much does it depreciate, right? So we can just, in this case, divide these numbers. And so let's see what we get when we divide negative 4,677 by 3. That's negative 1,559. So again, that's dollars per 1 year. So now this value is what our slope is. So now we can put it together, say, okay, v is negative 1,559 times t. And then plus the initial value of 23,500. So this is really cool because you don't have to, any year, if you want to figure out how much your car will be worth in, 5 years or 6 years, you could just plug it in here instead of doing all the work each time. Okay, our third and last example for applications of linear stuff is with economics. Okay, so it says it costs you $250 to make 7 units of a product and $400 to make 120 units. We're going to sell the product for $5 per unit. So if you don't like units, you can put in whatever you want there, anything at all. So part A, we're going to find the cost, revenue, and profit functions, assuming the cost is linear. And for part B, we're going to find how many units we must make and sell in order to break even. All right. So cost, revenue, profit, these 3 things they pop up a lot in these, right? Like almost every time, like we're finding these equations because they help us make sense of this whole situation. Okay, so cost being linear. Okay, cost being linear. What this means is that the cost equation looks like this, mx plus b. C equals mx plus b. Now I know that we've talked about that or the way that we can, write the cost equation is by a fixed cost, which is really represented by b here, plus variable cost times x. But here in this example, we aren't given what the fixed cost is, and we aren't given what the variable cost is. We just know how much it costs to make 2 different numbers of things, right? We know we have this pair, this thing here, and we have this pair that go together here. So basically what we've got is we're trying to find a linear equation, and we've got 2 points on the line. Okay, so for part A, if we're just going to consider cost first, what we have here, we know that the cost is linear, and we have the 2 points on the cost equation. So they're going to look like, so it's normally x comma y, so the points will be x comma c. Okay, now remember x in these is always the number of units or number of items. So we make 7 items and it costs us $250. So that'll be 7 comma 250. And then we also have 120 units that cost $400. So 120 comma 400. All right, we have to find M and we have to find B. Now M is usually change in Y over change in X, but here we're just looking at a formula for cost, C. So we should, write that accordingly. So delta C, or change in C over change in X. Okay, so, or we can write C2 minus C1 over X2 minus X1. All right, so if here's X1, here's C1, here's X2, here's C2. C2 is 400, C1 is 250, X2 is 120, and X1 is 7. And actually, I'm meant to make this 70. Sorry about that. Let's make this just a 70 here. I must have accidentally erased a 0, so 70 instead of 7. That makes a lot more sense based on the numbers that we have. All right, 400 minus 250 is 150. 120 minus 70 is 50, and so this gives us a slope of 3. All right, cool. Now we need the value of B. Okay, I hope you remember how to do this. But all we need to do is plug in a point. Either one of the points that we have here, either this one or this one, doesn't matter which. I'm just going to use this point here because the numbers are smaller. I don't know. So let's see, C equals 3x plus B. So let's make sure that you plug the points into the right spot. So the cost is 250 and X is 70. So we've got 250 and then 70. All right, 3 times 70 is 210. And so we'll subtract 210 from both sides, and that gives us that 40 is equal to B. Okay, so we have C equals 3x plus 40. Here's our cost equation. Right, now interpreting this, right, we can still have that same interpretation of the cost equation. So this 3, this is how much it costs to make 1 unit. Costs $3 to make 1 item or 1 unit. And then the 40, this is still a fixed cost. So maybe this would be the cost to rent the space, or I don't know, the cost for your tools or something that is not dependent on how many items that you make. All right, revenue is our next thing. So let's take a look at that. So we need to find the revenue equation. Now we have to remember some formulas here. Revenue is equal to price, little p, times X. Okay, now in the question, it says that we are going to sell each product for $5 a piece. All right, so that is our little p, or our price. Okay, so this is little p. So that's easy. That just means that our revenue equation is just going to be 5x. And once we have those two pieces, profit's pretty straightforward. We just take our revenue and we subtract cost. Okay, so let's see. Our revenue is 5x. Our cost is 3x plus 40. And we're subtracting the cost, which has two terms in it. So we really need to make sure all the time that we have parentheses around the cost equation when we're subtracting it. Because now we need to distribute the negative sign into here and here in order to combine like terms together. Okay, so we have 5x minus 3x minus 40. And so that means that if we combine our like terms together, this will give us 2x minus 40. And here's our profit. All right, part B, how many items or units must we make and sell in order to break even? All right, so we have to remember what break even means. So let us review that. Break even. That means that you don't make any money. You also, though, don't lose any money. So, right, that it's just on that fine line where you haven't made money, but you haven't lost any money. So there are two ways that you can think about breaking even. One of them is that revenue is equal to cost. Okay, you took in what you spent. You can also think of this as profit being zero. Okay, if your profit is positive, you've made money. If your profit is negative, you've lost money. I like this way, but either way will get you where you need to be. So all we're going to do is set profit equal to 0. So I'm going to take my 2x minus 40, set that equal to 0, and solve for x. Okay, so that gives us x equals 20. X equals 20, whatever's units, items we need to sell in order to break even. In the next video, our last topic in the linear equations review is about parallel and perpendicular. So I will see you there.